Okay. In today class, we are going to see about really one more important thing, but this one is very simple. Okay. Um, in real time embedded system, you need to be very careful regarding the time related stuffs. Okay. So the time critical operation you need to be perform properly, otherwise the embedded system that you are developing is not work properly. Okay. So what is the timing critical situation? So that is what we are going to discuss in this class. And yeah, two important things we are going to implement in this class. Okay. One is limitation of normal delay function, and non-blocking delay, that is we are going to use a timer. So that is really different from the normal delay. Okay. So what happen when we are using normal delay, and what happen when we are using our non-blocking delay? Okay, you need to understand, you are going to understand these two things, and that will be more useful when you are going to develop a real-time embedded devices. Okay. So okay, let's begin. Okay, let's open our Tinkercad. So we are going to implement everything in this. Okay. So I will create a new design, or else we already developed this push button with LED. Let's take this one. First of all, we are going to use normal delay, then we are going to observe the like limitation. Okay. Okay, let's see. So this is just sample program. What happened? Switch press means this LED will glow. Okay, that is the concept here. Okay, what I'm going to do, let me do one thing. Okay, we are going to add one more LED. Let's add that one more LED here, and we need to add resistor for that LED. Okay, like this. Okay, and we need to use any of the pin. I am taking the D5. Any pin you can use for LED, like the digital pin I'm saying. Okay, sorry, this one is cathode, right? So we should not connect here. This should be connected over here. Anode. Cathode should be always connected into the ground. Okay, so where is the ground? Yeah, we will take from here. Okay, let's change the color into black. Now we have successfully connected the LED with resistor. Change the value of the resistor into some kind of low value. Okay, 330 ohms will be perfect. Okay, now we have two LED. Let's change the color of this LED into some other green. Oh, sorry, I need to change here. Okay, green. Okay, now we have two LED. Okay, what will happen? This LED will normally blink. Okay, this LED only blink. I mean, sorry, this LED normally blink. This LED only get turned on when I am pressing the switch. Okay, there are two operations we are going to do. Okay, let's declare this green LED. Okay, uh, hash define. Sorry, what is the new LED? Green LED or something like that. You can use G LED. I am giving. That is fifth pin. Okay, and we need to set up that also pin mode GLED, that is output. Okay, sorry, yeah. So now we have configured the GLED, I mean green LED mode also, that is output mode, and we no need this one. Okay, this is only for when we are using serial monitor, then you need to use serial.begin. That's why I removed that line. Okay, now what we are going to do means here I'm just going to write normal LED blinking. Okay, here this is switch based switch checking, and here I'm going to write normal LED blinking. Okay, so how to do normal LED blinking? Everyone know that, right? How to do that? Digital read.
Digital read
Okay.
LED. Yeah, LED blink. Yes.
Okay, GLED, that is what we are going to do. High, sorry, and we are going to give a delay of, here we are going to delay 5 seconds. Okay, 5 seconds, or else we will move to the 4 second. And digital read, sorry, digital write. Okay, sorry, I'm given digital read. That's only used for reading the switch and reading the input devices. Here we are LED is output, right? We need to use digital write. Okay, so no one is said me to fix that, so please, if I'm making any error means make me know. Okay, delay 4000. Yeah, now it is normal LED blinking program. What it will do, first of all, turn on that green LED, and after 4 seconds this LED go off, and after 4 seconds again this loop is repeated. Okay, that is how it is working. Let's check. Okay, you can see the LED is glowing for 4 seconds, and for 4 seconds, like that it will working. You can see 4 seconds on, 4 seconds off, 4 seconds on, 4 seconds off. So like this it is working. Now I am going to press this switch. This switch should turn on this LED, right? So let's check that is working or not. You can see I am pressing the switch. It is not even working. This LED is not glowing. You can see I am zooming in so that you clearly see I am pressing or not. Okay, here you can, sorry, I am unable to drag this properly. Wait a second. Yeah, now you can see this LED is blinking 4 seconds. Now you can see I am pressing this button. You can see it is not even responding. See, so how to fix this? Somebody know how to make this LED glow? What is happened here? Okay, I will explain that one. Here actually we are doing LED blinking, right? What is actually happening here? We are giving the delay of 4 seconds, and after making the LED turn off, again we are giving delay 4 seconds. Okay, so what is it is doing exactly? 4 seconds the CPU completely stuck here. Okay, this delay, what it will do, completely stop every operation in the CPU. Just CPU is frozen. So whenever we are pressing the switch, it is missed. Okay, you can see this switch, this statement for switch checking only happen after this 4 second. It happen, and instantly it goes to the this delay. It trap on this delay, like this delay stopping the checking of the switch. Okay, that is the really important. This code is working, but only for very few microseconds or milliseconds, like that. So that's why whenever I am pressing the switch, it is not making the LED glow. Okay, now you can notice that I am start the simulation. I am continuously pressing the switch. Now you can see this LED is glowing. So how it is working? So I will explain that. So only this statement is checked after this 8-second delay, that means 4 second, 4 second, 8-second delay, it is checked, but quickly it goes to the delay again. So that's why you can see I am pressing the switch, it is not working now. You can see not working. So when I am pressing continuously, this delay, after this delay, when it is coming here, I am continuously pressing right. So it comes like the switch press is worked once. But in real time embedded system, like consider we are using we are in hospital or something like that. So you have an emergency button like this. So you are calling for emergency. Whenever you are clicking this button, this LED, the emergency is not working. So that is really like very dangerous, right? So this switch should work always without blocking the CPU. So that is the non-blocking delay we are going to create. Okay. So how to create that? I will explain that. So you understand that delay concept, right? The CPU is completely freezing here. It is not even coming here, only coming, but even after come, it suddenly goes to the delay and just freeze on this delay. So that's why we need to create a non-blocking delay using timer. Okay, the timer thing we are going to work in this class. In Arduino or ESP, whenever we are programming, there is something called millis function. So what is millis? Millis in
Some
Arduino.
milliseconds, sir.
Yeah, millis. Okay, you are saying that. Okay, I am saying this millis function in Arduino is a built-in function that returns the number of milliseconds that have passed since the Arduino board began. So what it will do, this millis function, whenever your Arduino wake up, that means I am start the simulation. You can see this LED showing green, right? This one turned on. So whenever the Arduino is turned on, from that time the millis function start to count. Okay, now I will say with the oral example, you can see I'm stop the simulation. Wait a second. Yeah, this LED is not glowing. Okay, now the CPU is sleeping. Okay, now whenever I am start the simulation, the LED turned on. From this time it will start to count background 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. Continuously it is counting inside. So that is the purpose of the millis function. The millis function in Arduino is a built-in function that returns the number of milliseconds that have passed since the Arduino board began. Yeah, millis is representing the milliseconds as you said, but what it is actually representing means whenever your Arduino is started, on that time it is continuously count the counting. Okay, start the counting like 1, 2, 3, 4, 5, 6, 7, like that it start to counting. That is the timer. Okay, it is primarily used for non-blocking timing, allowing the Arduino to perform other tasks while waiting for a specific duration. Unlike delay, this is normal delay function which halts the program execution, which means completely stop the CPU. That is should be avoided. Okay, so let's see how to create a delay without blocking the CPU. That is the timer we are going to use, default timer that is built-in function in the Arduino, that is millis. So how to create that? I will say that I already have that one. Okay, I will close this one. Okay, now we are going to create a separate function. Okay, this one, NB or non-blocking delay, you can write anything here. And what we are actually doing, this millis function we are calling. Okay, and minus T. T means the millis. The millis means this is the function that start to count. Okay, that start to count from the, like whenever the Arduino is powered, the millis start to count. This function start to count inside that, like 1, 2, 3, 4, like that it start to count. Okay, what we are doing, we are counting that number and storing into a variable t. Okay, and we are here doing some kind of calculation, that is millis function minus t. Okay, t means that is this one, previous duration or something like that, and that is less than duration. Duration means we are going to give some kind of millisecond duration. According to that it will work. Okay, now this is just a formula. Okay, millis of minus t and less than duration. It is compulsory, you need to declare the variable here for t. This will store the previous millis value. Millis values means there is millisecond value that is counted by the Arduino from the beginning. What it will do, I will say that initially millis have some kind of value, some kind of millisecond is inside that. Okay, that is stored into t, and current millis, I mean current value, current time value minus previous value, that is previous timing value. It is compare that, and duration we need to give, that is 1000 millisecond, 2000 milliseconds, we need to give, pass into this function. Okay, that is what we are given here for argument unsigned long duration. Inside this void function we are giving some kind of arguments. Okay, we are passing some kind of argument, that is duration. So what you need to do here, I will say that just NB delay, okay, or else non-blocking delay, whatever you can give for this function name. So I just use non-blocking delay. Okay, here you can see previously we have struggled to check the switch. Okay, now you can see I am using the non-blocking delay, that we have created in our own, non-blocking and non-blocking, sorry, non-blocking. Okay, non-blocking delay we are using, instead of normal delay we are using non-blocking delay. Let's check this one and observe the output. Okay, okay, now you can see this LED is blinking for 4 seconds, which means this is our previous condition, normal condition. You can see this one, 4 second on, 4 second off, that is what it is doing. Okay, but now it is using non-blocking delay, which means this counting time is happening in by the millis function, not stopping the CPU. Okay, now you can observe whenever I am pressing this switch, this LED should glow. Okay, let's check that output. Okay, you can see it is continuously working. I am pressing this switch only one time. Let's observe the output. Okay, this is actually we need to change the function, I guess. No issue, if we get some error means we will fix that. I will say that why it is happening. I'm continuously pressing the switch. Okay, what we need to do, instead of checking here, I will do some change. Okay, I will do here. Okay, I will stop the simulation. So why I am giving inside this, I will explain. Okay, no need to worry. If it is working, then I will explain why I am given inside this while. Okay, so I am remove this one. Now let's start our simulation. Okay, now it is working properly. Let's check. This LED is glowing for 4 seconds. 4 seconds on. Okay, it is staying on. it should go off, right? 4 second off. This is working properly. 4 seconds off and 4 seconds on. It should get on. It taking some time. You can see. So now I am pressing the switch. It should turn on this LED. You can see this is working. Whenever I am pressing the switch, it is like this LED glowing without freezing the CPU. You understand, right? You can see this LED is using the delay, but still I am able to work this LED. You can see this LED is working separately. This is handled separately. You can see this LED, whenever I am pressing the switch, this LED is working. Also, this delay is happening in background. Okay, let's start to analyze the code. Okay, you no need to worry. I will explain that. Okay, here we are using void loop function. That is normal. We are giving turn on the green LED and given non-blocking delay for 4 seconds. That is 4000 milliseconds. And again I am going to turn off the LED, and I am waiting for using the delay, non-blocking delay for 4 seconds. That is 4000 milliseconds. Okay. During this 4000 milliseconds, you can see whatever happening, like I need to check, I am given inside this while loop. Okay, you can see this is our function created void non-blocking delay. I will clearly separate this one, then you may get idea. Okay, just understand this. Okay, now you can see this void non-blocking delay. This is complete function. Okay, and this one is also okay. Wait a second. Yeah, you can see here this complete function is here. Okay, this while is started from here to here, and this is if else statement. In this if else statement, I am checking this button which is pressed or not. After that, I am storing I am using one while function. What it is while function, why I am using this one, I will explain that. This while function, what it will do, it start count using the millis. That means millis current value is some other, like consider any kind of value. Millis is decided by Arduino, which means Arduino continuously counting the number in background using this function. Minus t. T means that is our previous millis value. That is we stored here. Okay, that is minus current value minus previous value. Then we are comparing the duration. What we have given duration in argument 4000 milliseconds. If previous counting minus current value counted is less than less than 4000 duration means, then this while like it is not happen. When it is crossing the 4000, that means for more than 4000 means the while statement go to the false. While of 0 it will come. So this should not be executed. Only until 4000 milliseconds this inside this while is executed. Okay, so what it will conclude, what I'm conclude in this means, whenever you are using this non-blocking delay function that we have created, this 4000 milliseconds is counted by the millis function. Okay, not by normal delay. This millis function counting the 4000 milliseconds, what we are saying to that millis function, whenever you are counting that millis value, do this in background. What we are giving here, we are checking this switch. Okay, So timing is background it is counting. Timing is counted in background. On the time, parallelly we are checking the switch also. Okay, this means this will handled separately, this LED, and this LED is whenever this delay is creating or millis is creating, parallelly we are checking the switch also and doing this make this LED glow. So we are not freezing the CPU here. That is the main concept you need to understand from this. Okay, we are not freezing the CPU. Instead, we are what we are doing, how we are counting the seconds using the millis function. We are not stopping the CPU. So now when timing critical situation, you are in hospital like that, this LED is like normal operation. 4000 second the LED turned on, sorry, 4000 milliseconds this LED turned on, and after 4000 milliseconds this LED goes off. This is one kind of operation in hospital, one kind of thing is happening in hospital. Suddenly emergency situation, something is occurring, you need to press this button. Previously this button is not worked, right? Continuously pressing, sometime it will rarely worked, but now you no need to worry. Whenever you are pressing the button, the emergency light should glow, because we are counting the time in background, and in that background while counting you need to check this switch also, like that we set to the Arduino board. Okay, so whenever I am pressing this switch, this LED should glow, even though this the green LED process is happening. Okay, you can see whenever I am pressing this green LED is glowing now. I am pressing the switch, it should glow. You can see whenever I am pressing, the red LED glow, and timing also handled in background. Okay, so that is not disturbing this LED, this switch. So that is you need to observe from this class. Non-blocking delay is really critical in real-time embedded system. So that's why you need to understand this. Mainly you need to understand the single line. This is some kind of formula. Okay, you no need to worry on this to calculate the duration of the counting using the millis function. Okay, so yeah, I will share this complete project with our in our group. So you understand the concept, right? We are not blocking the CPU. Instead, we are using this millis function and counting the time in background. This will make the system work on any time. Anytime you can press the switch, that will work. Okay, that means we are not stopping the CPU because of the delay. We are created a new function, our own function called a non-blocking delay, and used that in while loop for creating the delay. Okay, hope you understand this one. Any doubt regarding this topic, how the non-blocking delay, like any kind of doubt you can ask now, I will explain. Okay, yeah.
Yeah. So can you please explain the code? I mean the void non-blocking. I mean the void non-blocking code again. So
Okay, yeah,
I
yeah,
couldn't
sure.
understand that.
Okay, I will
Yeah.
explain this one. No need to worry. Okay, I will zoom this out so that you understand clearly. Okay, or else I am taking this code completely into my compiler. Control C and opening my compiler. Just a few seconds. Okay. Okay, this is our code actually. I will say that how it is working. Okay. So what we are doing initially, we are creating a variable called t. Okay, that can be anything. I'm just giving t, or else we will store previous time. Okay, and this t is replaced with previous time. Okay, I will explain this one step by step. Okay, you no need to worry on confusing or anything. Okay, this one is end of the while loop, this one is end of the while loop. Okay, and this one is end of the function. Okay, hope you understand that one, these brackets. So initially we are creating a variable called previous time. Okay, in previous time we are storing the millis function. Okay, let me take my pen. Okay, here I'm go to the desktop. Here you can see this is the millis function. Okay, initially we don't know which value is inside the millis. Consider we have 500. Okay, 500 or something like that. That will store into the previous time. That means stored into the this variable. Okay,
Like the other LED, the green LED blinked for 500 millisecond. Are you talking about that things?
yeah, I will say that what we are given, this function we have called, right, non-blocking delay. So what it will do, we are passed that something like that in our code, non-blocking delay of 4000 milliseconds, that like that we have given, right? So what it will do, this 4000 come to this function here. Okay, and that is stored into the duration variable. So this 4000 will be sit here. I will show that. So now the formula will look like this, 4000. Okay, now the previous time we already know, that is 500. Okay, now this is millis. Again I am calling that millis, which means current time. Current time means the time we are calculating, like which is 5000 means, like on that time when the CPU counted 5000, like initially it counted only 500. When it counted 5000 means that is 5000 minus 500 according to this formula. This is the formula, 5000 minus 500, 4500. Okay, 4500 is not less than 4000, it is greater than. So this while loop inside it will not work. What it will do, only like consider we are having the 4500 counting only, or 4000 yeah 500, let's take 4500 we have. Now the current millis value 4500, previously it only counted for 500. 4500 minus 500, 4000, or else we are giving here 4001, like that, you imagine that one. So 4001 is less than 4000 less than is 4001. That means 4000 is less than 4001, like that. So that is true, which means until the condition is true, this switch is checked continuously. Okay, hope you understand. This will be little confusing. So just understand, until this 4000 millisecond, this switch is continuously checked. Okay, what we are doing in LED thing, you can see here. I will go back to the wait a second, go back to our program, then you clearly understand. Okay, here in our program I am make the LED high and calling the function for 4000 duration. So this function will be executed, and in happening 4000 millisecond, background it is checking the switch. After the LED gone off, again we are giving 4000 milliseconds. So what it will do, millis again start to count, and while counting in background we are checking the switch is pressed or not. You can see switch is pressed or not, like that we are checking in background, which means whenever the counting is happening in background we are checking the switch. Okay, it means it will not block the CPU. the switch is checked continuously even when we are counting the delay, non-blocking delay. So this will be if you understand, clearly listened means, hope you get clear on this one, at least 70 to 90%.
Yeah.
Still if you
Yeah.
have still you have doubt means no issue. This will be only understand after a lot of time practicing. Okay, so just we are counting the duration.
you.
Okay, yeah.
Yeah.
So please, if you are still having the doubt means, do try your own. Still you are facing like it is only confusing means, you can personally message me. I will make some other kind of counting method. Yeah, like this formula is same, so I can create a function like some other simple. Okay, but this one is mostly I researched a lot of things, simple formula, then I took this one. So still if you are doubting means, no issue, you can come to me. I will change some function and I will teach you. Now by I said,
Sure.
you may understand
Thank you.
some, properly. Hope you understand one. No issue if you still confusing, keep practicing, you will get that concept. Okay, so yeah, that's
Sure.
about non-blocking delay. I will share this project, no worries. Okay, into our group I will share this one. uh, any other doubt, or else we will end up. Any other doubts?
No, sir. No doubts.
Okay, for anyone other, or we will end up the class. See, this is only like 30 minutes one I already said. Because of the doubt, only it extended some more. No issue. So I will stop the class recording.